Alrighty, in this video we're going to look at combining index laws. Now when we're combining index laws, there's 5 rules which I've taken from the textbook which will help you to be able to do that. The first of those rules says that if you can simplify an expression with indices, it's often going to require more than one index law. Okay, so you can't go into any problem assuming that you're only going to have to apply the first index law or just the fifth one or so on. You're going to have to probably use 1 and 5 or 3 and 6. You're going to have to use a couple of them. The second thing to remember is if an expression contains brackets, you've got to get rid of those first. That should be the first step in simplifying any expression. Get rid of the brackets first. So you've got to get rid of the brackets. The third one, if the expression contains fractions, first simplify across the fraction. So if you've got a to the 3, b to the 4, a to the 6 over a to the 4, b to the 3, a to the 2, first do something about these two a's on top. So that's going across, and also these a's on the bottom. Got to do something about those first before you then go up and down and do whatever the a's are on top divided by whatever the a's are on the bottom, and then the b's on the b on top and b on the bottom. So first go across, which means deal with whatever you've got on top and then deal with whatever you've got on bottom, and then you can do the division of the top by the bottom. Okay, so that's the third thing to remember. When you do the fourth thing, when you're dividing fractions, you can change the division to a multiply and flip the second fraction. So that's a situation like this, where you've got a to the 4 divided by a to the negative 3, where we can say a to the negative 3 is really 1 over a to the 3. So that's what we've got on the bottom. We've got a to the 4 on top, and on the bottom we've got 1 over a to the 3, because that equals that. And so this fourth thing is reminding you that when you've got something divided by a fraction, and you can actually consider this on top to be a fraction too, I can rewrite that equation like this: a to the 4 over 1, because anything is just itself divided by 1, and that's being divided by 1 over a to the 3. I've just rewritten this like this over here, so we've got a fraction divided by a fraction. Okay, we can rewrite that as a to the 4 over 1 times, flip this upside down, a to the 3 over 1. Okay, and then it becomes a lot easier. We just do the top times the top and the bottom times the bottom. So a to the 4 plus 3 now. We're multiplying these two indices together, so we add the indices and divide by 1 on the bottom, so that's, doesn't need to be written. And then we've got a to the 7. We don't need to write the divided by 1. Okay, and finally, express the final answer with positive indices. So anytime you've got an a to the negative 3 somewhere, you've got to turn that into 1 over a to the 3. And if you had b to the 3 divided by a to the negative 4, then that's going to become a to the 4 b to the 3. If you've got a negative indice on the bottom, it can be put on the top as a positive indice. So you've got to get rid of any negative indices where they appear. Okay, so let's do some worked examples of those that will require us to use these 5 rules for combining index laws. Okay, here's our first problem. So we've got something inside some brackets, and that's been raised to a power, and then it's been multiplied by this thing over here. So the first thing that we should do is get rid of those brackets. In order to do that, we've got to apply the fourth and the fifth index laws here, and here's how we do that. So the fourth index law says anything that's inside these brackets has to be raised to this third power out here, and the fifth index law says that I've got to apply that third power to each of the things inside the brackets. So any powers inside here get multiplied by the 3, and it's got to be done to each of the things inside. So So getting rid of these brackets is going to mean 3 to the power of 3, because you can imagine there's a 1 here, and it's 1 times 3, so that gives 3 to the power of 3. A to the power of 2, the 2 gets multiplied by 3, so that becomes 6. B to the power of 2, the 2 gets multiplied by 3, so that becomes b to the power of 6. And then we can rewrite this other part here, times 2, a to the 4, and b to the 3. Okay. So now we can apply the first index law for multiplying things that have the same base and different indices. So that's going to mean we've got 3 to the power of 3 times 2. Although they don't have the same base, they're numbers, so we can work those out. And then a to the power of 6 times a to the power of 4. And then b to the power of 6 times b to the power of 3. So I'm just pairing up all the things that have like terms or like bases. 3 to the power of 3 is 3 times 3 times 3, which is 27. And then that's multiplied by 2. A to the power of 6 times a to the 4, we add the bases, so add the indices together. So we get a to the 10. And then b to the power of 6 plus 3 is b to the 9. So this comes out to be 54, a10, b to the 9. Okay, now that seems like a lot of stuff, a lot of working out. But the thing with these index laws is you just take it one at a time. At each stage, the application of one of the laws isn't that hard. And once you do each of the steps one by one, you end up with a nice result at the end. So you just got to keep pushing through them. Alright, let's do another one. Okay, here's another problem. So this time we've got something on top which already looks to be pretty well simplified, but on the bottom we've got some brackets that we need to get rid of. So first let's get rid of those brackets. Alright, the top bit's going to stay the same, so I'll just rewrite that. And then on the bottom we've got 2 inside the brackets, and outside the brackets is a power of 3, so that's got to get raised to the power of 3. Remember, it's like a 2 to the power of 1, 1 times 3. And then we've got a to the power of 3, 3 times 3 is 9, and b to the power of 3 just becomes b to the power of 3, because that's b to the power of 1. Okay, now we've got this, we can do some simplification. So on the bottom, that's going to become an 8. 2 times 2 times 2 is 8. So then we've got 5 over 8, which we can't simplify. We've got a to the 2, and it's divided by a to the 9, so that's going to be 2 minus 9. So on top we're going to have 2 minus 9 is negative 7. And we've got b to the 3 divided by b to the 3, which just equals 1. They cancel each other out, so we can write 1 there, but what would be the point of that? Okay, so can we do anything with this? Well, we've got a negative power here, and we don't like to have those. So a to the negative 7 becomes 1 over a to the power of 7. So we can rewrite that as 5 divided by 8a to the power of 7. I've just put the a to the 7 on the bottom. So there we go. Okay, in this problem, we've got one sort of thing here on top of the fraction, and it's being multiplied by another thing over here. And on the bottom we've got something that already looks fairly simple. So if you remember the bits of advice that we looked at the start, it says we should deal with simplification across the fraction before we deal with doing the top divided by the bottom. So first let's see if we can do anything about this bit on the top here. So we've got 2 and a 3, so we can multiply those together and get 6. We've got a to the power of 2 times a to the power of 3, so we've got the same base, we can add their indices together. That's going to be a to the 5. And we've got b to the power of 1 times b to the power of 4. We can add their indices together because they've got the same base. That's going to be b to the 5 as well. And that's been divided by 4, a to the 3, b to the 5. Now 6 over 4 we can simplify to 3 on 2. And then a to the 5 minus a to the 3 is going to be a to the 2. We're minus 3 from 5. And then b to the 5 divided by b to the 5 is just 1, which we don't need. There's no point writing it. So we can just leave that out. So there we go. That's as simple as you can make it. Okay, in this problem, we've got a fraction times a fraction, and we've got to decide, are we going to divide this by this bit here on the bottom, and then divide this by this bit here on the bottom, and then multiply it together, or are we going to do, because we've got a fraction times a fraction, we're going to do the top times the top, and the bottom times the bottom first, and then at the end we'll have one fraction that we can divide. It's going to be a lot easier if we do it the second way. If we multiply this top by the top and the bottom by the bottom, then we're only going to have to do one division at the end, which is better, because division's a little bit harder than multiplication. So let's do the top times the top. We don't have any numbers in the first section, so it's just going to be 2. You can imagine there's a 1 out the front there, so it's 1 times 2. Then a to the power of 3 times a to the power of 6. Add the indices, a to the power of 9. B to the 2 times b to the 1. Add the indices, b to the 3. And then that's divided by, again, there's only one number, so it's just 5. A to the 4 times a to the 9 is a to the 13. B to the 7 times b to the 3 is b to the 10. Okay, now we can do the division of the top by the bottom. So 2 to the 5, that's going to stay the same, 2 over 5. A to the 9 divided by a to the 13, 9 minus 13 means we're going to have a to the negative 4. And then b to the 3 minus 10 is going to be b to the negative 7. Okay, now we don't want to have these negative indices, so we can just put them straight onto the bottom and make them positive. Hopefully you're getting the hang of doing that by now. So it's just going to be 2 divided by 5, a to the 4, b to the 7. And we're done. Okay, so here we've got another situation of a fraction, two fractions, but this time they're being divided instead of multiplied together. But as you recall, one of our bits of advice at the beginning was when we've got a fraction divided by a fraction, we can rewrite that by flipping the second fraction over and changing it to a multiplication, which is just great, isn't it? So again, we're going to go across before we go down. So we'll do the top part here times the top part here, and we'll do the bottom part here times the bottom part here, because this is flipped around now. So this is the top and this is the bottom. So on the top, we've got 5 times 3 is 15. A to the 2 times a is just going to be a to the 3. B to the 3 times b to the 6 is going to be b to the 9. And then divided by 6 times, there's no number here, so it's just 6. A to the 7 times a to the 9 is a to the 16. B to the 5 times b to the 4 is b to the 9. Okay, so far so good. Now, can we simplify this? 15 and 6, we can divide both of those by 3, so let's change it to 5 over 3. And then a to the 3 minus a to the 16. We could put a to the negative 13 up here. 3 minus 16 is negative 13. But hopefully we're getting to the point where we can see where that's going to go. A to the negative 13 is just going to end up on the bottom. So let's just put it straight onto the bottom there. A to the 13. And then b to the 9 divided by b to the 9. The b disappears. It would just be 1. We don't need to write that. So there we go. There's our final answer. 5 divided by 3 times a to the power of 13. Okay, so here's another problem. This one's starting to look pretty nasty. But there's a couple of things that are going to make it a lot easier. If we look through the equation, we see a couple of times where there's something to the power of 0. And straight away we should recognize we can simplify that. Anything to the power of 0, doesn't matter what it is, we can ignore whatever's in here. If it's to the power of 0, it's 1. So that makes that a bit easier to deal with. This is also to the power of 0, so that's going to become 1. So we can rewrite this equation straight away as 5 to the negative 3. Negative 3 times 5 is going to be 5 to the power of negative 15. And that's going to be divided by 5 to the power of 6. 6 times negative 3 is negative 18. And this is times, I should put this in brackets, times 2 to the negative 1. Actually, I don't need the brackets there. So negative 1 times negative 3 is 3. Okay, now there's a couple of ways you could deal with this 5 to the negative 15 divided by 5 to the negative 18. One straightforward way is just to say they've got the same base, and the second one's being it's a division, so it's negative 15 minus this power here, which is negative 18. The two negatives become a plus, so it's negative 15 plus 18, and I'll put the time 2 to the power 3 there. Negative 15 plus 18 would be 5 to the negative 3, and then that's being multiplied by 2 to the 3. 5 times 5 times 5 is 125, and 2 times 2 times 2 is 8. So 125 times 8, that turns out to be 1,000. So isn't it funny? All that complicated stuff reduces to this nice simple round number. Okay, so hopefully those examples give you a pretty good grounding, pretty good ability to be able to work out these index law problems. And just make sure you've written down, just trying to find my highlighter pen here, just make sure that you've written down these kind of guides for combining index laws. Make sure you've written those down in your exercise book. Remember, anything that's coloured in yellow, that's got to be copied into your book. So you can pause the video if you like and copy that stuff into your book. Okay, thanks very much for watching. I hope you enjoyed the video.